We're talking about the abacus, and what we're doing is we're learning how to read the abacus. When we learn how to read the abacus, welcome, welcome, welcome. When we learn how to read the abacus, what are we doing? We are counting on this thing. What is this thing? This thing is to count the abacus, counting numbers. We're just going to count. We're just going to count and understand. So this is 0 because all the beads are 0. And then what I'm going to do is I'm going to do 1. 1 and then 2. After 2 is 3, right? After 3 is 4. All these beads that are touching is a value of 4. All the 4. So what does it mean? That means that this horizontal bar is counting the beads. So when the beads are touching the horizontal bar, this is what's being counted. Now when we look, we have 5. This is the value of 5. How do I know? Well, that's just the way it is. So that's the value of 5 because this is 5, and then we can count after 5. We can count higher than 5. We have 5, and then this is 6. After 6, this is 7. After 7 is 8, and then we have 9. And so when we look, we have 9. Every column will have 9. That's what it is. So when we look, we have 1, 2, 3, 4. Oh, yeah. That's cool. You could see my TikTok shop. There's a little thing at the bottom. Oh, that's cool. Okay, cool. I was wondering about that. Okay. So that's the cool thing. Okay, so you can actually get my abacus on the TikTok shop. That's cool. Okay. So how do we know? We have 5. This is 5. Now notice I did this and this is 1. But when I add the 5, because the top beat is 5, now I have, what do I have? I have 6. So when I have 2, this is 1, 2, and I add the 5, the top beat is 5, I can have 7, 5, 6, 7. 5 and then 2 beads. This is what 7 looks like. 5 plus 2 is 7. And then we have 3. When we have 3, 1, 2, 3, and then we have add the 5, now we have 8. So when we look, this is 8. Can I make that better? Oh, that's not good. There we go. There we go. So, anybody have any questions? Hello, hello. Okay. Okay. So we have 8. Now notice we have this one. This was 4, right? We have 4. We have 4. But then when you add the 5, now we have 9. Thank you so much for the likes and the hearts. Thank you so much for the hearts. Let me know if you have any questions. But right now, what we're doing is we're trying to learn how to read the abacus. So when we read the abacus, and then after 9, so if you look, all of these are 9. But then how do you do 10? Well, 10, it looks like this. I have my 0, and I have my 1, and that's what 10 looks like. What? That doesn't make sense at all. This is why we want to understand how to read the abacus. To read the abacus, you'll notice that they have every column is a place value. Because every column has a place value, now we know how to make a 10. This is a 0 and this is a 1. 0, 1. So when I look at 11, all it is just 1 and 1. Just how we write 11, 1 and 1. And then we have 12, 1 and 2, 1, 2. That's how we do 12. What? Why? Because when we look at the place value, we have our ones, our tens, our hundreds, our thousands, our 10,000. And if you look, now we have place values located on our abacus because our abacus helps us track our numbers. When we look, we can do 1, 2, 3, 4, and then 5. Because we have 5, we do 6, 7, 8, 9. And then after 9, we have 10. This is what 10 looks like. 10, I'm at work right now, but I love these lessons. Oh, hey, Ashley, thank you so much. I'm always live, so you can always come back later. I don't want to disturb you. But I'm so happy you're here because you're the only one chatting. So I feel like I'm not the only one in the room. Thank you. I appreciate you commenting. So let me talk about how to make 11. So we're going to do 11. There's 11. And then we have 12. We have 12. 1 and 2. And then let me know if you have any questions. And then we have 13. How do we do 13? Well, 13 is 1 and 3. And then 14 is 1 and 4. When we look, thank you, Red, but you can be just as smart. You can be smart too. Because what we're going to do is we're going to learn how to read the abacus. And when we learn how to read the abacus, we are going to be able to do some adding, subtracting, multiplication, division on the abacus. So the reason why I want to tell you guys, I want to get you guys to know how to use the abacus. Let me know, Red, if you have any questions. So, hello, Joe, welcome. I see you're on, but my other one is not on. I see he's not on. Okay, So what we're going to do is we're going to talk about 0. This is 0. Why is this 0? Because none of the beads are touching this horizontal bar. Because they're none. Hey, lady, welcome back. Because none of the beads are touching the horizontal bar, this is now considered 0. When we do 1, we have 1. And then we have 2, we have 2. We have 3, and then 4. Because we have 4, I'm going to go keep up the good work. Thank you, Red. I hope to see you soon. So then we have 4. Because we have 4 and it's touching the horizontal bar, this is what we are reading. We have 4. Now we have 5. Hello, Cabell? Cabello. Hello, Cabello Kim. This is the value of 5. Because this is the value of 5, now we have 6. We have 1 and then 6. So notice we're going to add the top bead. The top bead will always be 5. Because we add the 5, now we have 6. So notice if I have 2, 1, 2, and I add the 5, now we have 7. So we have 5 and 2 is equal to 7. We have 3, 1, 2, 3. Notice there's only 3 beads, but then when we add the 5, we have 8. How do I know? Because the top bead will always be the value of 5. So we have 8. 5 plus 3 is 8. That's how we get 8. And then we have 9. 4 plus 5 is 9. Hello. Good evening. Good evening. I'm so happy you're here. Just reviewing some abacus and looking at some chats. Let me know if you have any questions. Oh, yes. I would love to see some subtraction after reviewing how to read the abacus. Oh, yeah, for sure. We will go into adding, subtracting, multiplication, division. Hello. Hello, Minta Maddie. Am I Mountain? Okay. So again, we're just going to review. What we can do is we can understand how to read the abacus, and if we look, okay, you know what? If we look, I'm not sure who else is here, but let's see. If I did this number and I did this number, what number do you think this is? So if I have this number, and don't forget, I have my tens and I have my ones. When I have my tens and my ones, what number do we think this is? Please put it in the chat. Please put in the chat what number you think this is. Thank you. Thank you. 90, actually 80. How do I know it's 80? Oh, almost, Zen Gilbert, because you got the 3 and the 2, but we have to add the 5. So what we're doing is we're going to add the 5. The top bead always has a value of 5. So when we look, it's 5, 6, 7, 8. And then, yes, thank you, Lady E. Here is 7. 5, 6, 7. So Zen, does that make sense? We have 87 because we have the 5 at the top. When we look, what you had was 32. 32 looks like this when none of the top beads are touching the horizontal bar. Yeah. And so that was the one thing to understand when we read the abacus. Once we understand how to read the abacus, we'll go into adding and subtracting and multiplication division. So let's do another one. Here is a little maze that I have created. And what we're going to do is we're going to look at the maze. And we're going to let me know in the chat, what number do you think this is? Let me see if I can find my mask maze. So here's my mask maze, and this is my little number. My number is what? What is my number? If I show you on my abacus, I have this and I have that. So then my number is, yes, thank you, Lady E, 61. How do I know it's 61? Because this is my tens and this is my ones. So I have my 1 and then 60, 5, 6. So then, thank you. S with carrots, I think it is. Thank you. So then what I'm going to do is I'm going to color in 61. When I color in 61, I'm going to go to the next box, and this box is what? This box is that number and then this. So what we're reading is our 2-digit numbers. This is a 2-digit number. Hey, B, welcome back. So this is a 2-digit number, and we're looking at the tens and the ones, and it's actually 39. Thank you, Lady E. Yeah, I know, typo. Thank you, Zen. Yes. So it's 39. 1, 2, 3 in the tens column, and 9. 5, 6, 7, 8, 9. So we have 39, and I'm going to color it in, and then I go up to here. Oh, you guys can't see the next number. There's the next number. There it is. And so when I yes, thank you. 87 and 39. Yes, thank you. And then we have the next one is we have a 5 and a 1, right? We have a 51. Yes. Fantastic. Thank you. Yeah. Typo. Yes, it is. It is 51. And I'm going to color it in. And then I have this. So if I look, okay, this will be the last one. That one and then this one, because I think we're getting it, right? Thank you. Yes, thank you, Zen. 64. Good. So we have 6 and a 4. 5, 6. 1, 2, 3, 4. There we go. Okay. So it seems like that it's okay, and it's only 9 of us. So, and nobody else has been commenting. It seems like you guys really understand it. Does that make sense, or do we want to keep going? We can keep going with recognizing the numbers, or we can go. We can go into adding and subtracting more. Oh, hey, B. Oh, oops. Okay. Okay, I didn't know you were still around. So here, what number would this be? This is an easy number. What number is that? So if I did that, that would be the number 3. Thank you. Thank you, Lady E. Thank you, Zen. B, are you all right? B, 43. It is not. It is not. Because the 4, then none of the beads are touching the horizontal bar. Only the 3 is touching. So when we look, that's 3. So now we have this one. This one should be easy. Yes, thank you. Mint. Am I in, I don't know, mountain in 99? Yeah, it is 99. How do we know that this is 99? Because we have this, we have that. We have, I'm sorry, we have this and that. So now we know we have 5, 6, 7, 8, 9, and then 5, 6, 7, 8, 9. So notice when we look at it, this is the top bead. The top bead will always be 5. Because the top bead is 5, this is 6. So when we add, so what you had before B was 66. That's what 66 looks like. But then when we do 5, 6, 7, 8, 9, right? This is 9. So we do it again. 5, 6, 7, 8, 9. And so we have 99 is our answer. Great. Make sense? And then we're going to go into this one. And what is the next number? We are still working our tens. I'm trying to find my. There it is. So I'm still trying to find my tens. Yes, good, lady. Yes, good. Thank you. Here's my little label that says my tens and my ones. My tens and my ones. Thank you. Yes, 91 because it's 90, because it's 90 and it's 1. Great. So then we have this one. We have the tens, and then we have the ones. What number do we think that is? Yes, good, lady. Nope, it's 50. It's a 5, not a 6, because we have 5, 6, 7. This is 70, and then we have 5. So this is 6 would look like that. That's what 6 would look like. So it's actually 75. We're 75, and now we're over here. Yes, 54. Yes, 54, because it's a 5 and a 4. And we have a couple of more, and then we're almost done. Yes, thank you. Sincere. This is fun. Thank you. No, thank you, B. I appreciate that you commented, because if you didn't, we would have gone different. But yes, let me know. This book is actually available on Amazon, and I'm going to try to get into my TikTok shop. I haven't gone there yet. I actually just published it. Actually, it's not 50. It's not 24. 24 looks like this. 1, 2, 3, 4. The top beat is always the value of 5. So it's actually going to be 25. Oh, yeah. There you go. There you go, B. 25 it is. Yep. 54. Yep. Okay. So we have 25. We have 2 left. 2 left. Zen, I don't know if Zen's still here. Oh, can't see it. And then we have this one. We have this number. And then we have 5, 6, 7, 8. 5, 6, 7, 8. 58. Thank you. Zen, it is actually 58. Yeah, there you go. There you go. Yeah, it's a typo. I know. I know. Because everybody, we all have fat fingers. And then our final one is the answer to the universe. What number is this? If I show you this, And that's the answer. What is the final answer? Yes, the answer to the universe is 42. Why is it the answer to the universe? It's one of those books that I read called The Hitchhiker's Guide to the Galaxy. And that book has the answer to the universe is 42. I thought it was funny. So, and then if you're ever interested, this book is available. And all it is just recognizing what the two-digit numbers are. And that's all it is. And it is available on Amazon, and I'm going to bring it into my shop. But I have it here, and I'm on my 10th book, actually. Quite excited. But my name is Lynette. Hello. I teach abacus. I've been teaching abacus for 20 plus years now, and I'm here to teach the world how to use the abacus. I am very happy you guys are here. Let me know if you have any questions. So, the other one was a reverse maze. The reverse maze means what? Well, the idea was that I give you a box, a template of what the abacus is, and then you're going to have to find your way. So here, I give you the number and I give you the path, and you're going to have to color it in. So the path, the number that I'm going to do is 68. So I have to put 60 and then 8, 5, 6, 7, 8, and then it takes me to here, to this box. And then to figure out what number this is, I need to see this path right here. So this is what I call a reverse maze, and because you can also do some coloring. So the idea here was just to like get you to be interactive and notice how to read the abacus. And this specific book is only 2 digits. I am working on a book that has 3 digits, 4 digits, and there will be a 5 digit. Yeah. Is this the book of 10? No, this is not the book of 10. The book of 10, the book 10 is this one here. So I actually have two sets of books for the how to make a 10. This is to for those people that that don't know. This is abacus is a specific method, and we have special we have a method to work our questions and our answers. And so what I did was I have these workbooks that I've created. This one is the 10 book where I have activities and exercises how to make a 10. Ah, this is cool. I enjoyed my time learning. Ah, thank you, B. I hope to see you in my next live. So what we're doing here is understanding how to make a 10. And then this one goes all the way to how to make a 10 with the plus 10s and minus 10s and so forth. Oh, maybe I should take this out. Oh, you know what? That's what I'm going to do. So when we look at it, this is all the 10s. And then the activities we have is there's instructions how to make a 10. There's the activities to enforce how to understand what the 10 is. And then we have, what do you call it? Where is it? It is the um, spinning wheel. So the spinning wheel, you take a little paper clip and you spin it, and then you figure out where it lands, and you have to tell me if it's an evens and an odd, and then from here you have to put it in. And then here is where you start to do your adding and subtracting. So but this is just a little overview of how to make a 10. And so thank you very much for asking. We have, if you wanted more practice, I did make another book that says extra. And all it is specific questions, how to make a 5, and there are only 3 digits across, 3 digits down. But it's to help to solidify the concept of how to make a 10. So there's two sets of books, and that is how to make a 10. I am working on how to make minus 10. So that's the other thing. I this one I believe is a I don't know if I don't think it's available in my TikTok shop yet, but I will get it available. I just need to build out my shop. So that's what that is. That's what the 10 is. But so the first thing we're going to do is we're going to understand how to move the beads. So this is where we're going to start doing is we're going to start learning how to move the beads. That means we're going to start doing some simple adding and subtracting. What does that mean? Well, the first thing we did is, if you notice, is we did some bead recognition. Because we did bead recognition, we just did a one-to-one, and that's what this is. This was more geared towards, kids who don't know their numbers. So I had it where they have some activities, how to count forward and how to count backwards. Let me know if you have any questions. But what we're going to do is we're going to do some adding. Simple adding. What does that mean? Well, in school, we need to do is we do not, in school, we focus on the result. But in Abacus World, we focus in on the add-in. This is the add-in. So what that means is if I look at this number and I have my question, I have my 5, I'm going to add 5 on my abacus. I add 5 on my abacus. And then what do I do is I want to add the 1. When I add the 1, that is my add-in, right? My add-in is not my focus is not how to make a 6. My focus is what do I do to add the 1. So when I add the 1, I'm just going to move the 1 bead. Notice if I have 6, so my final answer is 6. Notice I have 6, I want to add another 1. I'm only going to add this 1 bead. Notice when I go up to the horizontal bar, I'm adding 1. When I subtract away from the horizontal bar, now I'm subtracting, right? So going to the horizontal bar means I'm adding. Away from the horizontal bar is subtracting. And you can find this you can find this abacus in my TikTok shop. Anybody have any questions? Let me know. And then what we're going to do is we're going to continue on. The way the book is broken up is I have it by adding 1. And again, we could do the same thing. If I have 7 and then I add the 1, all I'm doing is moving the 1 bead up. And then I have the 1 bead down. I do add or I subtract. I add or I subtract. And then after 1 is 2. It's the same thing, right? We want to make sure we understand how to add. When we have 6, I want to add 2. When I add the 2 beads, I'm not going to be 1, 2. I'm going to add the 2 beads. I'm going to move it together at the same time. Now, before I continue, I want to show how the beads are constructed. If you notice, the beads there's a ridge. You use the ridge to help you move the beads. So even though you have big fat pudgy fingers, right? You should be able to use the beads still because you're using the edge of the bead. This is a standardized and standard size abacus. If you notice, right, I have this one, which is only 7 columns, and then I also have this one, which is a 13 column. The 13 column one, if you notice, is exactly the same. It just doesn't have as many colors. They work exactly the same except this one has 13 columns, because size matters. Because size matters. Now you might be wondering, there's these dots that are over here. These dots are my ones indicator. These are my ones indicator. It tells me that which ones is the ones. Because it tells me which one's the ones, then I can guesstimate how big my number will be. So if I chose this to be my ones, it'd be my ones, tens, hundred, thousands, 10,000s, and so forth. So I choose this to be my ones. I have my ones, thousands, millions, and then billions. But wanted to track if I wanted to track the national debt, I would have to get a bigger abacus because this is a 23 column abacus. Because of the 23 column abacus, it just has more beads. More columns means more digits. So when I look, this one has been with me for about 20 plus years. I've been actually teaching on this one. This is my personal one. This one is made out of bamboo, but these ones here, they're made out of plastic, but they work exactly the same. It doesn't matter. It doesn't matter if it's plastic or if it's made out of wood. But if you notice, when you work with an abacus, you need to stabilize the abacus. Why? Because if you don't stabilize the abacus, it will be easy to move. The beads are very easy to move. So just so you know, when you look at it, you have to make sure it's stable and make sure when you use the abacus that's on a flat surface or else your numbers will be off. And then the other thing is don't flick too hard. So if I do this, you'll notice that some of my beads moved up because I flicked too hard. Like Zeus and Thor, he flicked too hard. Is there a reason why the fifth vertical row is the ones place? The difference is I decided to choose my dot indicator, but that's a very good question. So if you look, I have dot indicators, and these dot indicators are my ones place. So I could choose, hey E, I could choose any one of these dots just like a Pokemon. I choose you, right? So just like that. I choose this one to be my ones place. I choose this one. I love the content. Thank you, E. I try to be corny because I love being corny. Um, so Sincere, did that make sense? You can choose any one of the dots as long as you just choose one. And it's all about perspective. It all depends on how big your number will be. If you want to choose this one, then your number will have a lot of decimals. So if you notice the ones happen, right? There's the ones, and then after the ones is my decimal, and then after the decimal is my tenths and my hundredths and my thousands. Okay, so we have that. We have that. Okay, good. Yeah, let me know if you have any more questions. I do appreciate any of the comments and the questions because about abacus, please. Um, and again, what we're doing is we're adding the two. When we add the two, we're only moving the two beats. That's what we're doing. And then obviously there's two, then there's three. After three, right? How do I know this is three? Well, when I look at it, I want to add the five. I'm going to add the five. I'm going to add the five. When I add the five, notice I'm stabilizing the abacus. When I add the five and I want to add the three, I'm going to add these three beats. All I'm doing is moving it up. And then again, when I subtract, I'm moving it away from the horizontal bar. I add, goes up to the bar. I subtract, it goes away from the bar. So that's what it is. And then four is the same, four and minus four. And then the question is always, do I have enough? Can we do it? Yes, we can. Can you add the five? Yes, I can. So I'm going to add the five. Can I take away the five? Yes, I'm going to take away the five. Oh, sorry. Watching from South Africa. Thanks for this. We'll definitely be buying the books on Amazon. Oh, yeah. You're welcome. Thank you. I do have a few books available on Amazon. I do see you. But thank you for watching, and I do go live pretty often, and if you have any questions, let me know. I gotta go. Thank you, Zen. No, thank you, Zen, for commenting. I do appreciate it. I'm happy that I'm not in this room by myself. Okay, so when I look, I have two, and when I add two, I'm going to add another two, right? So that's two and two. Okay, we're done with that. Are we done with this? Yeah. And then we know that we need to subtract. We need to subtract. We're going to move it away. When I subtract the five, I'm going to move it away. I'll move it away from the horizontal bar. When I add the five, I put it to the bar. It's the same thing with the six. So when I do the six, I'm going to bring it together, right? I add the six. If I have one, I'm going to add six. I'm going to take one top beat and one bottom beat. I bring it together. When I take it away, when I subtract, I move it away from the horizontal bar. So this is what I'm doing. So the number is seven, and when I take away six, I'm moving the six away from the horizontal bar, and that's how I work, right? So my final answer is one. So we did simple. This is what happens when we have enough. I was like, can we do it? Yes, we can. We have enough. So now what happens? Well, what happens when there's not enough? That's the question. That's the big question. So what happens when we don't have enough? Well, if we don't have enough, then we have this concept that we need to understand. What is this concept? The concept is how to make a five. So in mainstream math, we're understanding how to make a five. What does that mean? Well, what it means is we don't when the abacus doesn't have enough beads. When does that ever happen? It happens when we want to add the three. I'm going to add the three to the abacus, and then I'm going to add four. Notice on my abacus I don't have enough beads to add a four. When I don't have a four, this is my question, right? Three plus four. Like, we know this, yes, but teaching children, they don't know this, and I don't want them to memorize just random numbers, right? I don't want them to memorize how to just four plus four. I don't want them to memorize doubles. What I want them to memorize is this concept. This concept is 4 plus 1 is equal to 5. Why are we doing the 5? Because we're going to utilize this freeloading 5. All my numbers is going to be working for me. I need to make them work. So when I make them work, this is what we're going to do is we're going to add this thing. But what we need to do is we need to change out our equation. So what we're going to do is we're going to isolate the variable, right? Isolating a variable means that we're going to make the 4 by itself. How do we do that? Well, if you notice, if I make these two equal, they don't equal, right? What we have to do is we have to balance the equation because this is not balanced. To balance this equation, we're going to minus the 1. Does that make sense? Then what we're going to do is we're going to substitute this information into this 4. When you look, I'm going to add the 5. I'm going to take away the 1. And so my final answer is 7. Does that make sense? So what did we just do? What we're doing is we're understanding the constraints of the abacus. We're understanding the constraints of the numbers. And so what we do is we have these fundamental elements that we can build. And as we build, right, it's like little Lego pieces. We can build off of this. Oh my God. Is that a good thing or a bad thing? Is this it? Let me do that. Let me do this. Let me do this. It's this. Did that work? So what we're trying to do is we're trying to understand how we move the beads. So let's take it one more step further. We're going to make it more versatile. I'm not memorizing my doubles. What I'm going to do is I'm going to memorize this formula. I'm going to memorize this concept. This is the concept that we are learning. We are teaching the kids how this concept, but we're going to take it one step further. So the question is what? The question is when I add the 4, do I have enough beats to add the 4? No, I don't have enough beats to add the 4. Well, how can I add the 4? If I don't have enough beats to add the 4, what am I going to do? Well, all I got to do is follow the directions. This is the directions. I want to add the 5 and take away the 1. All I have to do is add the 5, take away the 1. And my final answer is 8. Please repeat. Yes, we will continue to understand this. So what we're doing is we are taking this information, right? 4 plus 1 is equal to 5. When we have 4 plus 1 equal to 5, what we're going to do is we're going to isolate this variable. To isolate the variable, it's like a little bit like the beginning of algebra. It looks very similar, right? X plus 1 is equal to 5. When we isolate this variable, we need to add this, we need to subtract the 1 to the other side. So what we're doing is we're balancing the equation. When we look at it, we do X is equal to 5 minus 1. Because what we did is we take away the 1 on both sides. Does that make sense, Zamel? I don't know if anybody else is here. So I don't know if that's a oh my god, that's too complicated, or that's a oh my god, I see the light. um, MNT Mountain. Did that make sense? Timante. Did that make sense? Okay, so we're gonna continue on. So my final answer is 8. Again, we are not memorizing doubles. We're not memorizing the strategy of doubles or doubles plus 1. What we're going to do is memorize our formula. We can do it again to show you how versatile it is. So here's my question is 2. When I have my question is 2, notice I don't have enough beats to add the 2. Well, what do? I know I'm going to minus the 5. I'm sorry, plus the 5 minus the 1. I'm going to plus the 5. I'm going to take away the 1. And so my final answer is 6. When does this ever happen? Why are we doing this? Okay, so let's take it one more step. Here is some money. I'm not sure if you have a nickel. This nickel is worth 5 cents. This nickel is worth 5 cents. So the question is if I have two, if there's 2 cents, this is cents. This is 2 cents. But but it's worth 5 cents, right? I'm sorry, it's worth 4 cents. I only have this 5 cent. Because I only have 5 cents, I'm going to give this to you and you have to give me back some change. So I'm going to take this 1 penny, this 1 cent away. So then my final answer is 6. Does that make sense? So the reason why I do it with money, and I apologize if it doesn't translate into the other parts of the world, but that's the only thing I have for American money. I'm in America, just so you know. So we have 5 cents and we have pennies, and so this one is talking about 5 cents, which is called a nickel, and then pennies, which is 1 cent. Let me know if you have any questions about this concept. I want to be yeah. Does that make sense? Does the money make sense to you? So when we're looking at it, right? If there's 2 and I want to add the 4, but then the 5 is too much. Okay, good. Thank you, happy face. Because 5 is too much. If I give you the 5, we're going to trade it out. So I take the 1 back. So then my final answer is 6. That's how this works. So when we look, I have 2, and then I'm going to add my 5. I add the 5, but adding 5 is too much. Hey, Paula, I'm going to take away the 1. So my final answer is 6. So that's how it translates to the abacus. Okay, good. Okay, good. I'm so happy it makes sense. I hope it's not too complicated. because it's not meant to be complicated, it's meant to simplify. But see, the thing is once you understand this, then it's very scalable, because then it doesn't matter what question you have, it just matters how you do it. And again, we don't focus on the result, we focus on the add-in. So it's always about how do you add 4. Anybody have any questions? Any questions at all? Hello, Tay. Okay. If not, I'm going to continue on. We're going to do what? We can do more. You know why? Because we have these sets. So when we have these sets, we can do it for 3 as well. When we do it for 3, what does it look like? It looks very similar. So now what are we doing is we're compounding our knowledge. We're compounding our knowledge of this concept. Let's do 4 plus 3. We do 4 plus 3. So on my abacus, I'm going to add 4. I'm going to add the 3. Oh my God, I don't have enough to add the 3. What do? I need to isolate this variable. So when I isolate this variable, all I got to do is move this 2 to the other side. When I do that, it's 3 is equal to 5 minus 2. So now I have directions. I want to add 3 here. That's what my question is. I'm going to add 3. I add the 5 and I take away the 2. So my final answer is 7. It's the same thing. If I have 4, right, I have 4 pennies. 1, 2, 3, 4. I have 4 pennies. But the thing is only $3, 3 cents, right? I only have a penny. I only have a nickel. I only have 5 cents. I'm going to give you the 5 cents, but you got to give me my change back. To give me my change back, I'm going to take 2 away. So that's what we just did. We did an exchange. Oh, yeah, a trading in. That's beautiful. That's what we did. We're doing a trading in. Does that make sense? So this is what we do to make a 5. When we make a 5, hey, Picasso, welcome. That's a beautiful name. Okay, so these are the. Is there more? Wait, there's more, because you can add, subtract, multiply, and divide. But we're only touching the surface right now. There's still more. Wait, there's more. What do you mean there's more? There's more, but we're compounding, right? So when we look at this, we know how to add. Again, if we know how to add, we're going to know how to subtract. What does that mean? What are we going to do? We're going to subtract. We're going to subtract. So now we know how to add. What we're going to do is we're going to subtract. What we're going to do is we're going to minus the 3. We're going to take away 3. But I wrote it this way. What we did is we copied the question, we copied the equation, and we just changed out the operation, right? So now we're doing is minus. So if you look, we did plus here, we add 3 plus 2 is equal to plus 5. We're adding the 5. Now what we're going to do is we're going to take away the 5. When does that ever happen? That happens when we do 7 minus 3. Notice when we do 7 minus 3, there's my 7. I want to take away 3. There's not enough beads to take away the 3. There's only 2 beads to take away. There's not enough beads to take away the 3. So what do? I have to minus the 5. Minus 3 is equal to minus the 5 plus the 4. No, plus the 2. I'm sorry, plus the 2. Does that make sense? So what we're doing is we're going to minus the 5 and we add the 2. So my final answer is 4. Does that make sense? Are we okay? Yeah? Okay. Hello, user 1234. So what we're doing is we're adding and subtracting. So what we just did is we subtracted the minus 5. So we're going through the process of going through the abacus method. The first thing we need to do is we need to know how to read the beads. The next thing we need to do is understand how to move the beads. After we move the beads, then we go how to add and subtract. And then the question is how do we add and subtract when there's not enough beads? And that's what we're doing right now. What if there's not enough beads to add and subtract? Then we need to understand these formulas. So that's what this is. That's what these formulas are for. These formulas, thank you so much for that like, happy face. So what did we just do? We just understood how to utilize the formula. So this is the formula. Add the 4 minus the 4. Where's my other one? Minus the, I'm sorry, I'm trying to find all my little gadget thingies. So this one's the plus 5. This is the plus 5. So after the plus is the minus, right? So we did what I just showed you was how to add a 4. To add the 4 is plus the 5 minus the 1. Plus 3 is plus the 5 minus the 2. I just use imaginary numbers. You could use Bailey for imaginary numbers. Um, if you can work with scale, that's great. So this one is the minus the 4, and then this is minus the 4 minus the 5 plus the 1, and then this is minus the 3 is equal to minus the 5 plus the 2. So that's what we do. And cool. Let me know if you have any questions. We can go further into what's the next step. Well, the next step is understanding how to make a 10. So what we just did is we understood how to make a 5. We added the 5 and we subtracted the 5. So now the next step is to understand how to make a 10. What does that mean, how to make a 10? Well, we are teaching the kids how to what? How to carry on, right? We have these concepts that we're making a 10. When we make a 10, that's what we're doing, right? We have these like carry on, borrowing, trading. What's another word? Bailey, what do you do when you make a 10? How do you make a 10? Is it a make a 10? Or is it trading? Or is it regrouping? Or is it, what do you call it? Borrowing? I don't know. I don't know. What would you call it? What would you call these things? What would you call it? I would like to know. Does your imaginary numbers have names? Oh, I think Bailey left. Okay, since Bailey's not around. So what we're going to do is we're going to figure out how to make a 10. Why are we doing that? Well, we're going to do that because that's the next step. What? Why? Well, when we look, let me see. Let me find one. We'll do this one. That one. So this is how we're going to do is we're going to make an 8. We're going to use 8. Why? Because 8 is easier. It's not so confusing. So if you look, I have 7. When we have 7 on the abacus, right? We have 7 on the abacus. We have 7. And we have an abacus. And we're going to have 8. When we add the 8, we can't do it. So notice we can't do an 8. But we know the partner of 8. The partner of 8 is 2. And 2 plus 8 is equal to 10. 2 plus 8 is equal to 10. We understand this. Okay, great. 2 plus 8 is equal to 10. We understand that. But how are we going to make it into an abacus formula? To make it an abacus formula, if we're looking for an 8, we're going to isolate the variable. When we isolate the variable, what are we going to do? We're going to move this 2 to the other side. That means we're going to subtract it because we're going to make the 8 by itself. That's what isolating the variable means. So what happens is we do 8 is equal to plus the 10 minus the 2. So when we plus the 10 and we take away the 2, I have 7 on my abacus. Notice I cannot add any more 8. I can't add the 8 on the abacus. Because I cannot add the 8 on the abacus, I want to plus the 10 and then take away the 2. So my final answer is 15. Does that make sense? Anybody there? Bueller? Bueller? Yeah? Are we all right? Any questions? So again, if you notice, right, we had this concept, no questions. Smoking? Okay. I'm happy, I guess. It's kind of boring when people don't have questions. So what we're doing is we're taking this concept. We know this concept and we leveled it up. So after we leveled it up, it's the same concept. It's the plus 10s, but this instead of doing the plus 5s, we're doing the plus 10s. I'm happy to teacher. So when we add the 5 and then we make a 10. So after making the 5 and making the 10, that's how we do it. And that's it. So we can do it again. We can do 4. We have 4. I add the 4. And then what are we going to do? We're going to add the 8. When we add 8, we don't have enough beats to add the 8. What do? We have to plus the 10 minus the 2. And my final answer is 12. How are we doing? So my final answer is 12. Oh, good. Oh, good. I'm very happy. Thank you. I appreciate it, but you're the only one in the room. I'm just letting you know. So if you have any questions, let me know if you have any questions. We can continue on. I mean, this is usually just for adding and subtracting. And then what we could do is we could do multiplication and division. We can do multiplication division on the abacus. But what I started doing, adding and subtracting, thank you so much for liking the live. But what I'm doing adding and subtracting is because, at multiplication is just fast addition and fast division, fast subtraction. So we can do it again if we want to, or we can carry on to do the minus subtraction. What is subtraction? Well, subtraction is the opposite. So when we look, we have, thank you so much for the liking the live, Space Surfer. We have -2 -8. -2 -8 is equal to -10. I need division, but I didn't get to learn. I'm sorry, I moved to Mexico and do school over there. Oh, I need division. Do you know your multiplication table? We can do division on the abacus. I'm assuming you know how to do the abacus. So we can do division right now. I can show you right now. Since you're the only one here, we will go forward. Do you want to do, we can do division. Multiplication is just fast. Oh, there you are, Sincere. You're still here. Oh, yeah. Yeah, it's true, right? Because what is it? It's like 2 plus 2 plus 2 plus 2. So I didn't know you're still here, Sincere. So what do you want to do? You, what? A real one teacher. Oh, thank you. I appreciate that. Sincere, do you want to continue on with the plus and minus, or do you want to go on to adding, subtracting, or sorry, multiplication, division? We could do that too. It's okay. Whatever you guys want, because you guys are the only one that's commenting. If you don't comment, I don't know you're here. But yeah. All right. So before I go into Sincere, what do you want to do? Subtraction? Just tidying up around the house. More addition. More addition. Okay. So what we're going to do is we can look into smoking. I have a question. Do you know how to use the abacus smoking or not? Because it would depend on how difficult the question would be. That's the reason why. So here's a little activity that I made where we take the paper clip. I need to find a paper clip. I'm looking for a paper clip. I have a paper clip. And so we take this paper clip and we spin it. And if it lands on 13, then what we do is we put the 13 here. So it's supposed to be kind of interactive. And then the question here is 13 plus 7. So we have 13. We're going to add 13 on our abacus. We have 13, 1, and 3. That's how we do 7. And then we want to add the 7. When we add the 7, do we have enough to add the 7? No, we don't have enough to add the 7. What do? We know we need to plus the 7 is equal to plus the 10 minus 3. That's what we need to do. So what we're going to do is we're going to plus the 10. So we're going to add the 10 over here. It's 1 and 0. 1, 0. Plus the 10 and then take away the 3. So my final answer is 20. Yeah? Hi, baby. So we can do another one. So let's do this one here. We do 9. So my question is 9. When I add the 9, is there enough beats to add 7? I don't have enough beats to add the 7. So what do? I know I need to plus the 7 is equal to plus the 10 minus the 3. So I'm going to plus the 10, 1, 0, and I'm going to minus the 3, and I take away the 3. So my final answer is 16. Thank you so much for the hearts. Thank you so much for the hearts. I see you. I see you. Thank you. Can you reiterate 17? 13 plus 7. Oh, yeah, for sure, for sure. So I have 13. I have 1 and 3. Okay. I have 1 and 3. When I have 1 and 3, um, okay. So we have 13. 13 plus 7. Notice I don't have enough beads to add the 7. So because I don't have enough beads to add the 7, I need to find out my. Oh, you're still here. How do we know when to use the 10? Okay, let me finish this thought and I will get to your answer. Okay. So before I switch topics, not switch topics, but wait, expand on it. So what we're going to do is we're going to add the 7. Because we add the 7, we don't have enough beads. So what do? We know we're going to isolate the variable, and we're going to 7 is equal to what? Take the 3, move it to the other side. I'm going to plus the 7 is equal to plus the 10 minus the 3. So I'm going to plus this. Hey, Pancake, welcome back. So we're going to plus the 10. 1, 0. That's a 10. 1, 0. I'm going to add the 10, 1. I'm going to add the 1, and I'm going to take away the 3, and I take away the 3. So my final answer is 20. Okay, so then the question is how do we know when to use the 10? Well, when we don't have enough beads, got it, thank you. Yeah, not a problem. You're welcome, Sincere. When you don't have enough beads to add, that's when you need to use formulas. Does that make sense? So when we have 9 and I want to add 7, because that's the question, I want to add 7. I have 9 on my abacus. When I have 7, I don't have enough beads to add 7. Because I don't have enough beads to add the 7, what do? I need to use the formula. The formula is plus the 7 is equal to plus the 10 minus the 3. That's just something that we have to memorize. So when we add the 7, we're going to plus the 10 and then take away the 3. So my final answer is 16. Did that make sense? I'm sorry. I keep looking at your name. Tamati? I think it's Tamati. Mint Tamati. I would like to say your name better. Okay, good. Okay, good. You got it. Okay, good. But I apologize for not saying your name correctly. But I do see you. Okay. So do we want to continue on with adding and subtracting, or do you want to? We could do we could do subtracting. We can do subtracting is what? Subtracting is the minus the tens, which is where I'm trying to find. Oh, yeah. There we are. There we are. Oh, Esmeralda. Thank you, Esmeralda. Oh, it's a oh, I see. It's a clan name. Oh, I see. Esmeralda. That's a pretty name. I like that name. Okay, so let's do this. We'll do the question. I need paper. I need paper. So again, if you're looking for any of these books, they're either in my TikTok shop, um, or you can find me on Amazon. And my name is Lynette. Hello. I'm here. I've been teaching abacus for 20 plus years. I have 3 boys and they all gone through the abacus curriculum. I do believe that abacus is the greatest thing next to sliced bread. And I am here to make abacus more modern and popular. I'm trying to popularize abacus. And so that is why I am here and talking to you and teaching you guys how to use the abacus, because I think that is the greatest thing next to sliced bread. And the other thing is to show how easy it is to add and subtract. So we did a little bit about the plus 10. What we're going to do is we're going to do the minus 10. But I need to whoa. So okay. So what is the question? The question is 73 minus 3. Nope, 73. We'll do this one. 76 minus 3. 76 minus 3. So when we look, we have 76. And we need to take away the 3. When we take away the 3, is there enough beads to take away the 3? No, there isn't enough beads to take away the 3. How do we do it? How do we take away the 3? To take away the 3, all we need to do is remember we need to minus the 3 is equal to minus the 5 plus the 2. So we're going to minus the 5 and plus the 2. So my final answer is 73. 73. We can do it again with, let's see, okay, we'll do 77. So notice this is, I'm just showing you how versatile it is because we don't need to do anything else except understand. So we have 77. All we need to do is understand our formulas and it will fall into place. So we have 77. 77. We want to minus the 9. When we minus the 9, is there enough beads to take away the 9? No, there isn't. So what do we do? To minus the 9, we know that we're going to minus the 9 is equal to plus the 1 minus the 10. So we're going to plus the 1, and then we're going to take away the 10, and we take away the 10. Hello, Jazzy. Welcome back. So my final answer is 68. Thank you so much for sharing my live, Sincere. 68. 68. How are we doing? We all right? Thanks so much. Perfect timing finding your live. Oh, yeah. And you know what? And there's not a lot of people, so the questions can be questions can be answered. So if you have any questions, I am here. But yeah, I am going to build out my TikTok shop more. I have the abacus available, and I have the both the 7 column one and the 13 column one. Looking forward to being able to huge equations in my head with no effort. You could if you practice. I don't, but you could. Okay, so what are we doing? So we know how to do subtraction. We're all right. What we're going to do next is we're going to do some 2 digit. No, not 2 digit. We're going to do this thing called two-step. This two-step equation. What is a two-step equation? What is a two-step equation is when we start knowing and really understanding our fundamentals, and then we're going to Tetris our information. What does that mean, Tetris? Anybody play Tetris? Tetris is where you take a block, right, and then you try to figure out how it fits in. It's exactly the same as what this is going to be. So what question would that be? That question is this one. Um, we'll do this one. 5 plus, I'll show you the difference between them. So again, what we're doing is we're understanding why are we doing the add-ins? So here is the 5. I'm going to add 8 to my abacus. When I add 8 to my abacus, I'm going to add the 5. We know how to add the 5. We know this. What do we do? Plus the 5. We know plus the 5. How do we do it? Plus 5 is equal to plus the 10 minus the 5. So we're going to plus the 5. I'm sorry, plus the 10 minus the 5. So my final answer is 13. Right? Okay, fine. Oh, thank you, Sincere. Yes, right? That makes sense. Okay, now we're ready. Okay. So now what we're going to do is we're going to plus the 8. I have my 5. I'm going to add 5. I'm going to plus the 8. What is my formula to add the 8? Please let me know in the chat. What is my formula to add the 8? If I want to plus the 8 is equal to what? Yes, thank you, Pancake. It is. It's plus the 10 minus the 2. Thank you, Sincere. Yes. So I'm going to plus the 10. I'm going to take away the 2. Wow. I can't take away the 2. If I can't take away the 2, what can I do? Yes, Pancake. Exactly. We're going to go back to our 5 concept. So this is how we know that we're tetrising our thing. Well, it's the opposite. Yeah, you're right. So it's minus the 2. Minus the 2 is equal to minus the 5 plus the 3. So I'm going to minus the 5. I'm going to plus the 3. So my final answer is 13. But see the difference between the two? It's all about the add-in. It's all about this add-in right here. All depends on how do you add. And that's what abacus does. Abacus focuses on the add-in. We don't focus on the result because the result could be the same, but how you get there is always different, right? I'm hoping everybody wants to be happy, but how do you get to happiness is your own personal. Will you redo the 5 plus 8? Yes, I could redo it. So we have 5 on the abacus. We have 5 on the abacus. What we're going to do is we're going to add the 8. There's not enough beads to add the 8. Notice there's not enough beads to add the 8. We know what the formula is to plus the 8. To plus the 8 is what? Plus the 10 minus the 2. Plus the 10. 10 means what? We know that 10 means 0 and 1. So when I'm adding the 10, it's a 0 and 1. So yes, thank you, Sincere. We want to add the 10. When we add the 10, we have to take away the 2. Notice what? Notice what? Notice that I cannot find any of my stuff. Notice I want to take away the 2. I am unable to take away the 2. Why? Because I have a 5. There's no 2 beads here, right? How do I know? Remember, we're right here. I have the 5. We added our 10. We're here. We added our 10, right? Now I want to take away the 2. To take away the 2, there's not enough beads to take away the 2. What do I do? We know the formula we know the formula to minus the 2. This is why it's crucial to know your formulas. Minus the 2 is what? Minus the 5 plus the 3. So we're going to minus the 5 and then we're going to add the 3. So what is our answer? Our answer is 13. Sincere. Yes. So let's do Sincere's question. Sincere's question is, I need to move this. Sincere's question is 20 minus 12. When we do it, we do 20, 2 and 0, right? Let me move it. There we go. 2 and 0. We take away the 1, and now we have to take away the 2. When we take away the 2, there's not enough beads to take away the 2. What do? We know our formula. We know the pair. To take away the 2, we need to add the 8. Where's my... I'm going to take away the 2. Take away the 2 is what? Minus the 10 plus the 8. So I'm going to minus the 10 and plus the 8. So my final answer is 8. Does that make sense? Yeah? So this question is still pretty simple when you break up the numbers. Yeah? Ah, there we go. That's what you're looking for. Yep. Yeah? Cool? Make sense? Okay. This is not a two-step equation. This is just making borrowing a 10. Tick tock tocker. Yes. So let's do another one. Are we going to do another two-step? We can do another two-step. We could do 74 minus 6. Minus 6. So we have 74, we have 70, we have 4 on our abacus. We take away 6. How do we take away 6? We know minus 6. Minus 6 is minus the 10 plus the 4. So minus 6 is equal to minus the 10 plus the 4. So we're going to minus the 10. We're going to minus the 10. Now we need to add the 4. We cannot add the 4. How do we add the 4? Is there enough to add the 4? No. So what do? We add the 4 as what? Plus the 5 minus the 1. So we're going to plus the 5 minus the 1. So my final answer is 68. Yeah? Yeah. I think adding and subtracting is really fun. I think we just underrate it. Oh, I guess we can move this out. Yeah? Anybody have any questions? Excuse me. Anybody else has any questions? We can do another one. Let's do 64. 64 minus 9. So we had 64 on the abacus. 64. Right? Hello, Ninja Taco. 64. And we take away 9. When we take away 9, we want to take away 9 here. How do we minus the 9? Minus the 9 is what? Minus the 10 plus the 1. Minus 9 is equal to minus the 10 plus the 1. We're going to minus the 10. We're going to add the 1. I cannot add the 1. How do I add the 1? Excuse me, what formula do I need to add the 1? What formula do I need to add the 1? To add the 1, yes, thank you, Pancake, plus the 5 minus the 4. So my final answer is 55. Yeah, makes sense? I don't understand this. Oh, don't cry. Can you do mine? I'm trying. You want a cookie? Oh, okay. You want a cookie? Well, thank you for letting me know that you're trying. So when we read the abacus, we want to do 1, 2, 3, 4, right? So because the beads are touching the horizontal bar, this is 4. So when we have 5, we have 5. The top bead will always be 5, no matter what. So all of these, when they're touching like that, they're all 5. We have 5, 6, 5, 6. 5 plus 1 is 6, and then we have 7. 5 plus 2 is 7, and then we have 8. 5 plus 3 is 8. 5, 6, 7, 8. And then we have 9. 5, 6, 7, 8, 9. Does that make sense? You want a cookie? Yeah? Okay, good. So then what happens? What happens is how do you make a 10? Well, if you notice, this looks very familiar with this, but what's the difference? Every column is a place value. So if this is my ones, here's my 10. So when we count, we could do 10, 20, 30, 40, and then 50. The top beat is always 50. I'm sorry, the top beat is always 5, always has a value of 5, but because we're in this column, we now have 50. So we have 60, 70, 80, 90. After 90 is 100. Oh, looks familiar, doesn't it? Because we have a 1 and then we have our 100. We can do the same thing. This would be 1,000 and then this is 10,000. So the first thing we need to do is we need to understand how to read the abacus. Thank you for the follow. You want a cookie? Right? So when we look, we have 10,000. What we were doing is we were adding the abacus, and that gets a little bit more complicated. But the first thing we need to do, excuse me, kind of get it. Yeah, the first thing we need to do is understand that when you're moving the beads, you just want to move at the edges, right? So when we look, we have 5 plus 3. That's now 8. So when we add, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. So if I want to do 8 subtract 6, I do this. 6 is 5 and 6, and I take it away at the same time. So my final answer is 2. When I want to add 5, I want to go to the horizontal bar. When I want to subtract 6 again, I go away from the horizontal bar. Yeah, good. So now the question is do we have enough? What can you do one can you do this one integral of the constant function f(x) equals k? Vincent, that's above my pay grade. I have no clue what that means. I don't know what an integral is. I don't know what a constant function is. Sorry. If you can tell me how to make that into an arithmetic question, then I can tell you how to do it in adding, subtracting, multiplication, division. But if you can't tell me, then I can't tell you. So, what the abacus does is just does arithmetic. All the abacus does is just tracks your number, really. That's all it does. But you're doing the arithmetic yourself. So, if you did what? Fx equals k. I don't know. If x was 4, I don't know what f would be. You'd be dividing. So, you divide what? We could do k. I don't know. I don't know. Now I'm just shooting from the hip. Fx equals k. I don't know. 4 times 3 is equal to 12. That's what I see. I don't know if that's right. I don't know what integral of a constant function is. I'm sorry. That's above my pay grade. I'm a simpleton. All I know is how to add and subtract and multiply and divide. So the first thing we're going to do, okay, so you want a cookie. When we're going to do it is, the question is always going to be, do you have enough beads? Because why do we need to know if we have enough beads is when we start going into doing these formulas. The formulas that we have is 4 plus 1 is equal to 5. This is a concept that we're teaching the kids. We're teaching the kids how to do this concept. That means that we're going to be manipulating this. Does that make sense? You want a cookie? Yes. Okay, good. So I was just looking at trying to find a book. So in this one, what we're going to do is it was a -3, right? No, it was a +3. Yeah. So when we add the 3, no, it was this one. Sorry. So when we add the 3, we have the 3. When we add the 3, I want to add the 4. Now notice I want to add the 4. I don't have enough beads to add the 4. Now if you look, I'm going to add the 4. When I want to add the 4, there's not enough beads. I have this concept that we just showed you. The concept is 4 plus 1 is equal to 5. Well, why are we worrying about that? The reason why we think about it is because we can utilize this 5. We now no longer have any freeloading numbers. So we're going to add this 5. When we add the 5, we're going to isolate this variable, and we're going to move this 1 over to this side. What does that mean? When we make the 4 by itself, we have it 5, right? 4 equals to 5, and then it minus the 1 because we need to balance the equation. Does that make sense? Yes, thank you, Want a Cookie. Yes. So we're going to add the 5 and we're going to take away the 1. So my final answer is 7. Yes, I get it. Okay, good. Okay, good. So that's the question. That's the thing. And then obviously, if you know how to add, we can do the take away. What is the minus? The minus is minus 4 is equal to minus the 5 plus the 1. Same thing. So when the question is I don't know, 8 minus 4, right? We have 8. We have 8. That's not 8. We have 8. Again, we don't have enough beats to minus the 4. What do? We have to minus the 5 and plus the 1. So we have our final answer is 4. And that's it. And then we were going into how to make a 10. So you know how to make a 5, and now you know how to make a 10. That's it. And then what we were doing is we were doing this thing called two-step equation. So that's where you kind of came in, I believe, when we started doing a two-step equation. How do you Tetris your way through? Oh, thank you. I appreciate that. It's hard to, you know what? It's hard to, not hard. It takes me a little bit to know if a person is a spammer or not. That's what I notice. I take a little bit of time to figure that out. But yeah, no, great. I'm so happy that you understand. So then when we start going into here, this is what we call, I promise I'm not. Yeah. No, you're not, because your questions are very sincere. You know what I mean? Some people are like spammers. Anyways, so then that's when we start talking about this, right? We had 46. So I think you came in at this time where we had the 46. Sorry, 64. So we have 60 and we have the 4. And my question is minus the 9. When I minus the 9, I have my concept. My concept is minus the 9 is equal to minus the 10 plus the 1. So I'm going to minus the 10. I'm going to add the 1. And when I add the 1, there's not enough. So what do? When I add the 1, I have to plus the 5 minus the 4. So my final answer is 55. Thank you for the hearts. Yeah. Does that make sense? So what we were doing here is we're doing a two-step equation. This is a two-step equation because we don't have enough. But the thing is to see on what it looks like on your abacus. You know what I mean? So the abacus helps because it shows you whether or not you have enough beads to move. Oh wow. Okay, good. I hope that's a good wow. Some people are like, wow, that's really difficult. I'm I'm thinking adding is more easier. I think adding is more easier. Adding is more easier because I think we naturally go into it. So we can do it the other way. We could do this way. Let me do I see. It was because we were doing minus and I wanted to, yeah. So here we can do this. So we do 73. We do 73 plus 8, right? So we do 73, we add the 7, we add the 3. And then my question is plus the 8. Do we have enough beads to add the 8? No, we don't. What do? Plus 8, we know the formula, right? Why do we do? You could count, right? You could do what? The number line and count forward. But this, this is to like explain how do we do this? So knowing that the partner is plus the 2, right? We know that plus 8 is equal to plus the 10 minus the 2. So I'm going to plus the 10 and minus the 2. So my final answer is 86. 86. Subtraction is just the same because you could do the same thing. The only difference is whether or not it's a two-step equation. So when you walked in, it's not because it's a negative, it's not because it's a subtraction that it's difficult, it's because it's a two-step equation no matter what. 81. Oh, I did 70. Okay, sorry, yes. 73. Oh yeah. See? Yes, you're right. 81. Yes, because my abacus moved. Yes, you're right. You're absolutely right. Sorry. Thank you, Sincere. So when I was doing it, I did 73, 73. So plus the 10, minus the 2, and I get 81. Yes. Sorry, my bad. I homeschool my two kids. I find this fascinating. Hey, Panda Dolce, thank you. I appreciate that. I hope this works for you. But it's one thing to go through it. It's another thing to not be open to it. There's a few people that are not open. They're like, yeah, you make it really complicated. It's actually really not. Um, because it seems complicated to us because we know this in our heads because we're adults. But with the kids that are young, if what we do is we focus in on the formulas, we teach them already how to make a 10. But now what the abacus does is we take it one step further. So when we take it one step further, then that's what we do. So you notice that the partner of 8 is 2, and we know how to use it in the context of 10. So, Panda, let me know if you have any questions. Do you want me to you want to do a little review? We can do a little review. So here's the little review. We go to 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is considered counted. Because this is counted, then we do 5. 5, and then 6, 7, 8, 9, and then we have 10. So notice that this is 10. If you are interested in this is a reference to explain how to do this. Sure. Is there a curriculum that one can buy? How old are your kids? Because I have books. I haven't quite made it a specific grade curriculum, but I was thinking about they would be going by ages. See you later, want a cookie. Thank you for helping and teaching me to have a good day. Have a good day to you too. Third grade and sixth grade. Okay, this is too easy. I have these ones, and everybody has to start off with understanding how to read the abacus. There is one I haven't built one out that's specific to third grade, and I haven't built one out that's specific to sixth grade. But what I have done is put in my pieces, if that makes sense. So this one is how to identify the abacus, the 2-digit numbers, and this is a maze where they have to just kind of go through and figure out what number this is. So what we're trying to do here is we're trying to understand how to read the abacus, and it just happens to be in a maze. And so you start here, and then you figure out what this number is. I need some more work on my two-step problem is what they're called. I think they're called two-step. Abacus World doesn't call it two-step. We just call it mix because we mix everything. Um, but yeah. But to be solid in your fives and tens, you will be solid in your mix formulas. So, Panda, yeah. So this one here specifically is the abacus mazes, and it's a two-step where they can just kind of go through. And there's, I think, 14 pages, 14 mazes, and then after the maze, there's a reverse maze. So, if that makes sense, yeah, mix. Yeah, I think in abacus world we call it mixed, but yeah. But I'm trying to relate it to mainstream math. Oh, I do have a few. I have a few books on my TikTok shop, and I do also sell here. I'm on my 10th book. Just so you know, after you do some bead recognition, you do some simple adding, subtracting, and then after that, you can go into how to make a 5, and then we go into how to make a 10. And then after we how to make a 10, and then after we make how to make a 10, and then we go into multiplication and division. So, Space Surfer, what would be the reason for learning this as an adult or an older kid? It's like brain gymnastics. One, it would solidify or fill in the gaps to go into more complex math. And so I'm getting inoculated in the abacus world from the US, and the abacus seems a lot more functional. Thank you. Very nice. Thank you. No, I appreciate it. Surfer, where is Surfer? Comprehensive. It is comprehensive. It is, and I feel like it's a lot simpler to. So abacus, I feel like is the gateway to complex math. Space Surfer, does that make sense? So then it would be the same reason, like why do we do Sudoku as an adult, right? or the other one was word searches or crossword puzzles. It's to do brain gymnastics, and that's where I would go if you're an adult looking at how to use the abacus. Yes, different ways of learning to get the answers, further understanding the critical thinking of math. Yes, and so that's very true in the abacus world. So just for fun, just for educational fun, usually, yeah, it would be like, so Sudoku is just educational fun, right? It keeps you active. It's like also playing chess. Why do you play chess? You play chess because of the critical thinking and analysis. Abacus does the same thing. So one thing is to understand why we use the beads, or how, or why, when do you use the beads, right? When and how do you how do you get the answer that you need? Um, yeah, keep your mind active. Oh, um, yeah. So we did that. We did that. But yeah, I'm still in the process of building out my whole curriculum. But then what I want to do is I want to make it more grade specific. I didn't realize that it should be grade specific until I started doing TikTok lives. Yes, thank you, Space Surfer. No, I do appreciate your question because it's a very valid question. Like, why are we? When I was first learning abacus, I learned it when I was an adult, and it was only because my dad wanted to open up a learning center, brain gymnastics. What brought me? Yeah, yeah, and that's what it is, right? So, but I think that's what I like to do is I would probably for an adult or an older child, for the older kids, if they have gaps in their if they have gaps in their math, so we can also focus in on multiplication and division. So in our app in let's see, sometimes I don't know how old the children are, right? If the kids are a little bit older and they don't know their multiplication, it may be nice to be able to do some multiplication that's easy for them. So the abacus will help. Let's do some multiplication, and I'll show you how easy it is to do multiplication. 12 times 14. So what we're going to do on abacus is we're going to count our digits. We're going to know, why are we going to count the digits? We want to count the digits because we want to know where to put our numbers. So we have four. 1, 2, 3, 4. So the first thing we're going to do is going to put my finger on the fourth column. 1, 2, 3, 4. And then what we're going to do is we're going to multiply it out. We're going to do 1 times 1 is equal to 1. 1 times 1 is equal to 1. So 1 is a single digit, so I have to go back one column. So this is 1, but I have to go back one column and add the 1. This is just a rule. 2 times 1 is equal to 2. 2 is a single digit. I go back one column, I add the 2. I'm done with the 1. Now I need to, I'm sorry, that didn't, okay, I'm done with the 1. So what I'm going to do now is I need to count again where my answer is going to be. 1, 1, 2, 3. So I start from here. 1, 2, 3. 4 times 1 is equal to 4. 4 times 1 is equal to 4. I add 4, but 4 is a single digit. I go back one column and I add the 4. 4, when I add, what can I do? I need to plus the 5 minus the 1, right? And then what do I do? 4 times 2 is equal to 8. 8 is a single digit. I go back one column and I add the 8. So my final answer is 168. 168. So learning the abacus and doing, I still don't get this. Oh, you know what? Here. I got it. You know what it is? It's because it's the one digit, two digit. And I think that's what it is. Let me see if I can find a better one. I think it's 20, was it 26? Was it 23 times that by 6? Let's try that one. So the first thing we're going to do is we're going to say 1, 2, 3. 1, 2, 3. We know that. So the first thing we're going to do is we're going to, 6 times 2. 6 times 2 is equal to 12. I had my 1. I had 2. 6 times 3. 6 times 3 is 18. I have 1. I have 8. 5, 6, 7, 8. Does that make sense, Pancake? So then my final answer is 138. I wonder. Can we do one more? Yeah. Okay, here. I don't get it either. I just need to keep watching you break it down. Oh, okay. Well, don't forget multiplication is different, right? It's another process. So it would be like doing this. 23 times that by 6, right? How do we do that in regular math? We do 3 times 6 is 18. We do 1 and we do 8, right? And then what do? We bring down the 0 and we do 6 times 2. 6 times 2 is 12. 1 and 2. So then our final answer is 138. What I did is I did it backwards. I think I get it. Yeah. You're welcome. VTEX Beamer. Oh, so you did it by corresponding a place value with the yes. Yes. Hey Kat, welcome back. So you did them with the corresponding place values with the two yes, yes. So let's do it again, right? But you know what? I don't do it this way. I start with the 10. I start with this one first. I start here first, right? So if you notice 1, 2, 3, I do 6 times 2 first. 6 times 2 is 12. Notice it's 12. If I remove that 0, it's 12. So I do 1 and I do 2. Notice there's a 0 already here for me. I don't need to do that. I don't need to worry about the 0. But in mainstream math, you do because you're writing it out. Then what do? Then I do 18. 3 times 6 is 18. I add my 1. I add my 8. So I go from the bottom up is what I'm doing. I hope that makes sense. Yeah, we can do it again. We'll do it again. We'll do another one. Oh, we had 12 times 14. Let's do 12 times 14. 12 times 14 is a little bit more, right? Oh, what is it? Let's break it down. It might be a little bit more complicated because it's, right? We times that. What do we do first? We do 2 times 4 is 8 and then 4, right? And we bring down the 0 and then 2 and then, right? That's what we do. I never understood the mainstream math version either. And then, okay, wait, what? Right. So what did I just do? This is mainstream math, right? Why we do the 0 here? Because it's 10. 10 times 12 is, I'm sorry, I'm just waiting. Right, 10 times 2 is, yeah, 10 times 2 is equal to 12. Okay, so here's new math. Okay, let's do new math. New math is 10 times 10. 10 times 10 is equal to 100, right? 10 times 2 is 20. right? I'm obviously known to put the 0 down, but now learning why we put it. Oh, yeah, yeah. No, okay. Yeah. But this is the difference, right? 10 times 2 is equal to uh 20. Am I doing that? No, I'm sorry. I need another 0. Because I need two. No, 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 no. 10 times 2. Yeah, so that's 20. Sorry, sorry, sorry. I don't do new math. I don't do new math. I do abacus math. You're late today. Hey, balls. I, oh, yeah. Okay, so we did this, right? And then we got to do this. 4 times 10. 4 times 10 is equal to 40. And then 4 times 2 is equal to 8. This is what we're doing in new math. But we don't need to do it in new math. Why? Because we do it in abacus. In abacus, we do 1 times 1 is 1. 1, 2, 3, 4. We know we're going to be here because 1 times 1 is a 1 digit. So I add my 1 here. That's, I don't know, right? And then I do 2 times 1, but it's not 2 times 1, it's 10 times 2. 2 is still a single digit, so I go back 1 column, I add the 2. What's the finger twitching math I'm always seeing the Asians do called? It's called abacus. So then I'm done with this 1. Now I go 4 times 1. 1, 2, 3. 4 times 1 is 4. 4 is a single digit. I go back 1 column, I add the 4. So I add my 4, 5 plus 1. And then 4 times 8, I'm sorry, 4 times 2 is 8. 8's a single digit. I go back 1 column, I add my 8. Oh, wow. Wait, how did you get to know where to put the 1? Okay, wait. Okay, cat. So cat, it is what they're doing is abacus in their head. Yes, they're doing abacus in their head. Okay, cat. Remember what we do is we need to count the amount of digits. We count our digits 1, 2, 3, 4. Because we're going to start right around 4. This is where our answer is. So our answer is going to be right around 4. Now, when we multiply it out and my answer is 1, I know I have to go back 1 column. That is a rule. I get it regularly, but not on the abacus. Oh, I see. You know why? Because we go backwards. In mainstream, we go this way. In abacus world, we go from the big number first. So 120 first, and then the 480, 484, 48. So what we're doing is we're doing the 120 first, and then we add the 448. Sorry, I'm mixing up my words. So we're changing the process. We're changing the order of we're doing. Oh, that helps. Yeah. Yeah, it helps because we know one way, but now we're trying to solve it a new way. They visualize it in their head as a tool in the abacus. Yeah. Wait. I'm here. How do you get 120 again? Oh, um 10 times 10 times 12. 10 times 12. That's how you get 120. 1 is 1. 1 is, but you're doing 10 times 20. 10 times 2. 10 times 2 and 10 times 1. So you go back 14, right? You do this first. You do 12 times 4. And then what do we do? Then we do this, but it's actually 12 times 10 is equal to, because what is it broken up? 14 is really 10 and 4. I will be trying that. I thought it was more than that. Yeah. No, no, it's not. It's really quite simple, but breaking it down and trying to make it relate to what we know, that's the difference. Yeah. Yeah. See, in abacus, we do it this way, but we go left to right. Oh, we can do another one. Let's do another one. Let's do another one. All right. Let's see if this one works. 18 times that by 14. Again, we're going to count our digits. 1, 2, 3, 4. 1, 2, 3, 4. We're over here. Okay. 1 times 1 is equal to 1. 1 is a single digit. I go back one column. I add the 1. Why? Because if you notice, this is at the 100. That's at the 100. So if I look at it, it's actually 100. It's actually 10 times 10 is equal to 100. What's the difference? The difference is abacus does it by what is it? Abacus does it by the multiplication fact. If I wrote it out, it would look like this. So we're at 100. Does that make sense? Wait, then what do you do after one? Oh, we do 1 times 8. 1 times 8 is 8. 8 again is a single digit. So I go back one column, I add the 8. It would be the same thing if I did 10 times 8 is equal to 80. No, unicorn, when we do it, we're here. 1 times 1, right? And then 1 times 8. So you're multiplying it out. That was the breakdown. So what we're doing is we're doing distributive property. Oh my gosh. The best way to understand it is to think about it as if it's similar to drawing out division. Multiplication on the abacus is more moving across the equations, similar to how we do division. Yes. Then it, no, not yet, pancake. Why? Because when we're done with this, we got to go back out to the left side. 4 times 1 is equal to 4. It's the same thing as 4 times 10 is equal to 40. That's the first thing we need to do. Yeah, exactly, sincere. 1, 2, 3. 4 times 4. So we're going to add the 4 here, right? To add the 4 is plus the 10 minus the 6. Oh, I didn't finish that. Okay. And then what? 8 times 8 times 4 is 32, right? 8 times 4 is 32. Add the 3, add the 2, add the 3, add the 2. Yeah. But the difference is in mainstream math, we add in extra zeros because we need to. So it's 525. Yes, I believe it is. 252. Why do we go back when it's a single digit? Because we're trying to make a single digit into a double digit. So like when we talk about time, right now it's 12:07. Yes, I would like to go. Yes, give me a moment. Does that make sense? So when it's a single digit, we try to make it to double digit. So we have 06, 12:06, right? That yeah, the jingle is nostalgic. So that 1 is in the tens place. No, this 1 is in the hundreds place because it's 10 times 10 is equal to 100. Right. Yes. So that's how I figured to go back one column. Hundreds. Gotcha. Thank you. Yeah, not a problem, Sincere. Unicorn, does that make sense? I don't know if we're keeping track. Balls, you all right? Okay, yeah. Balls knows. So that's why that's sometimes people like to see it as a two-digit number, making a zero into a two-digit number. Addition. I'm just refreshing my memory. Oh yeah, I see. So like that's and I know and I feel like this makes more sense to me just because we want to make a because looking at it number like just like if we did 101, 102, right? We have to put in that zero. So let's say we make it into time. 1 o'clock, 101, 102. We have a two-digit number. Sometimes when we do what is it? Sometimes when we do uh, our dates, right? In two-digit year, two-digit month, two-digit day, right? So if it's April 5th, right? 05 and then 2025. We put a zero in. But if it's double digit, you would not go back. Correct. You wouldn't need to go back because if it's the same digit, so if I did 14, I don't need to go back. Can you do addition? Yeah, we could do addition, but I'm actually going to head out soon. Sorry, AJ edits. I am about to head out. Oh, I've been on for a little bit. Yeah, got it. Thanks. Yeah, not a problem, Kat. Thank you. But yeah, exactly. So because it's two digits, you stay where you are and just go and you work it out, right? Just like this. And if it's 94, right? It's still the same area. See that? If I broke it up, that's why we go back because it's a 0 and a 5. What day is it today? Today's Monday. Today's a big day. All right. Yeah, does that make sense? We can do adding, subtracting, multiplication, division. It just depends on the concepts, right? It does take a little bit. It makes a lot more sense now. Yeah, good. Good. It takes a little bit, right? I'm not saying you should know it overnight. I mean, this is not intuitive, but after you learn it more often, it comes a lot easier because there's rhythms and there's patterns and you'll start to see the patterns. But right now it's still very new, so you don't see the patterns. But when you start working with it, you will start seeing the patterns. That's why sometimes I forget, right? Because I already know the patterns. And so I forget what it's like to be a beginner. Like like I forgot that we used to do multiplication like this. I do multiplication like this now, if that makes sense, right? And exactly what Ball says, to do multiplication is just like division, but in horizontal term or horizontal way. Yeah, you're welcome. You're welcome. Yeah, if anybody was interested, I do sell this in my shop, and then I have like books. I'm still trying to expand my book collection on the shop. But I do have it. If you want to see my collection, it is here. Hi, my name is Lynette. I've been teaching abacus for 20 plus years, and I'm just now bringing it into the internet world. But yeah, thank you, thank you. But yeah, thank you guys for joining, and I do appreciate you guys having all the comments and questions. Um, yeah, and I hope to be able to live vicariously through. I feel like we get it faster if we had our own abacus to copy. Yes, you would. Because you have the physical thing there for you instead of me asking you and waiting, right? You could see it and you could see the pattern. So if it's for you, I would recommend the 13 column one. If it's for your child, I would recommend the 7 and then graduate them to a bigger one. So then it seems better. This would be a great tool to learn over the summer. Yeah, yeah, it would be a very good tool. and it was interesting. I'm actually in the process of breaking down a couple of abacus, not abacus, breaking down a workbook that a parent that's taking my online class. She's having some problems how to break down the information that's inside the workbook, and how do I make it how do I abacify her workbook into what abacus is. And so that's what I'm in the process of doing, and it's quite easy, like obviously because I know how to use abacus. And so I'm just building out some stuff for her. But yeah, that's what she's doing right now. Is she has a child that's in second grade. um yeah, I will get the 13 column one. Can you download a free abacus and put it in mainstream? Can you download a free abacus, put the live mainstream in a mini screen? You know what? My live is on TikTok. I'm sorry, my live is on YouTube. So if you want to follow me, I'm there. And if we ever have problems, it's there. And you can have it as a little mini screen. And yes, you can download a free abacus. I believe there's a abacus app. I have not built it yet, but there are plenty out there. You can find an abacus app, and you should be able to do that. And then if you go to YouTube, you can find my stream, and there it is. I hope that helps. Yeah, thank you. Thank you, Unicorn. I'm happy that you were here. Happy that you follow. But yeah, hey Ethan. Um so yeah. So if you want to, it is available on the stream is available. Whoops. Um on what is it? On YouTube. So you can go to my link in bio. Hello, Jose. I'm about to log off. I'm actually quite tired. I didn't realize how tired I am. Um sorry. I'm trying to preschool system is the only thing I can find on YouTube. My link is in my bio. Miss Lynette is my YouTube name. I'm about to head to work. Okay, good. Have a good day, Panda. Have a good day, Jose. I was actually about to sign off. I've been on for almost 2 hours. Yeah, not a problem. You're welcome, Queen. Cat, Queen. That's how tired I am. I'm so like, yeah, Panda. Yes. So if you look at I have the link in the bio is to my website and also to my YouTube. Yeah, you're welcome. And so if you want to review what we just did, it's all there. It should be there. Um, oh, I am quite tired. It's a little bit, going live all the time and with all the energy. I didn't realize how much energy it zaps. But I do appreciate all the comments and questions, and let me know. My name is Jose, but everyone I know actually calls me Panda, but Jose is 100%. Oh, Panda. That's funny. Okay, cool. Okay. Have a good day at work, Panda. And then Panda Dolce. If that makes sense. The second grader, the third grader, and the sixth grader, you still need to understand how to. Oh, thank you, balls. Uh, you still need to learn how to read the abacus, and then after we read the abacus, you go into adding, subtracting, and then after that, you can scale it. You can scale the questions, but you have to know the fundamentals first. So that's why I have the three four books. And then if you're looking for extra math, oh no, not that one. If you're looking for extra, it's available. Oh yeah. So what I did here is I broke up the plus tens, and if you wanted extra questions that are very number specific, I broke it up into the plus threes. So this one is 7 plus 3 and then plus the 6, and that's all it is. If you want extra practice. And then I have another book that comes in between. That's the minus fives, and then I'm working on the minus tens. But I make this one was more towards like young kids. I think I said like 5 to 7, 5 to 8. But the concepts, as long as they're how much are the books? Well, in the TikTok shop, I don't know. I think I'm selling it for 11.99. Or if you go to this one, the price is there. So Yeah, I gotta go too. I'll see you later, Kat. Have a good one. Do you have any to give away? Not right now. Sorry. All right. If nobody else has any more questions, see you later, Unicorn. I am going to sign off. Thank you guys for joining, and I will see you in my next live. Bye. Bye, balls. Bless you.